such a readiness to this event with people arriving before 8, as Rachael is telling me, and everybody seems to be ready to start. So that's absolutely great. We'll start with acknowledgement to the country, the QUT, and we all acknowledge the Tarwal and Yugara as the First Nations owners of the lands where QUT now stands. We pay our respect to their elders, laws, customs, and creation spirits. We recognize that these lands have always been places of teaching, research, and learning. Teaching, research, and learning. First, a few housekeeping notes. So, if anything happens, if any emergencies, this is the person knows exactly all the exits, what to do. So look at him and do whatever he says. Then the bathrooms are around the corner there. There are also clear signs. I don't think there's anything else which we need to know. Food will be provided at the right times, drinks, and so on. So if there's any issue or any problem, again, communicate about us. So today we'll be talking about fire. Without fire, we wouldn't be here. I mean, we, as civilization, we, as the planet, as the shape as it is. So the first continents emerged from fires. So fire was critical to this. Fast forward millions and millions of years, and this is in the British Museum, images of world's oldest known fire making. As civilization, we wouldn't be what we are without fire. But then there is another element of this. If it looks like this, it's a very different situation, very different story. To me, it was this fires of 2019-2020 was the first time I thought that Australians realized what it means air pollution. Because air quality in Australia is generally very, very good. So seeing people with masks on the streets, like here on Sydney, Brisbane, that was for the first time. For me, every morning when I go for a walk up the hill, across the streets where I live in Canberra, I see this sign. Bushfire risk is real around here. Bushfire risks, and when there's controlled burning, there's no risk, but the whole area is in smoke. We here, researchers, we come into this field from the angle of what's in the air quality, air pollution, and the impact on health. So right now I'm talking about the International Laboratory for Air Quality and Health here at QUT, which was established. I established it in 1993. Initially, its name was Environmental Aerosol Laboratory, which means the focus was on particles, specific particles. We've extended the name to air quality and health when we joined the WHO as a collaborating center. Because after all, particles are not in the air alone. There are gaseous pollutants, there's everything. And the clear focus has always been on health. So the purpose of what we are doing eventually is towards health. More recently, we expanded in terms of building this research center, Thrive, which is ARC-supported 3 projects. The main is the ITTC, Training and Transformation Center for Advanced Building Systems Against Airborne Infection Transmission, Linkage, and then my laureate fellowship, My Air, My Space, My Health, the science of buildings which help us thrive. So this is coming eventually health to help us thrive. Over those years, we've done a lot of work related to the topic of fires, to the topic of air pollution resulting from fires. These are just images in Brisbane, regional mitigation in relation to fires, to forest fires from different areas, and agricultural burning to control, to mitigate. But when stressing on showing these pictures, perhaps the most important is to realize that, again, that we are coming into this as scientists. So we need to understand what happens, how it happens, what's emitted, what are the quantities, what is the composition in the air. So our setups, experimental setups, look perhaps like this. This is one of the first setup to measure, and this is emissions from Australian trees. That's a stove you can see here, and the trolley with instrumentation. One of the first things which we did. For the next, well, I guess for the rest of today, we could be talking about many aspects of what we've done, what we've measured, but of course this is not the purpose why we are here. But I'll just show you in sort of rolling to see where we are coming from. Of course, our publication started coming from the 90s, but papers specifically related to this topic started coming about 2007. With the first one which we found with search for this topic, size distribution of particles emitted from grass fires in Northern Territory, Australia. That stove from the previous image was used for this. And then the topics we worked on. Biomass burning influence particle characteristics in Northern Territory, CO2 emissions from combustion of native Australian trees, biomass burning emissions of grass and gas and particles in marine, Green Tasmania, characterization of impact of open biomass burning, the ambient aerosol characterization during prescribed bushfire, biomass burning and biogenic aerosols during this particular campaign. Another aspect of this campaign, composition, size and cloud condensation, nuclear activities of biomass burning, emission of selected semi-volatile organic chemicals from forest and savanna fires, emissions from tropical savanna fires in Australia, a review of biomass burning emissions and impact on air quality and health and climate in China, air quality in Sydney metropolitan region during the Blue Mountains fires, to masks help and protect us during fires, the state of science on severe air pollution episodes, light absorption properties of black and brown carbon during prescribed burning, global population exposure to landscape fire, air pollution, response to low-cost sensors to high concentrations during bushfire and haze events, short-term exposure to wildlife, specific PM2.5, global, regional and national mortality burden attributed to landscape fires, respiratory risk from wildfires, health risk exposure to wildfire toxic air, impact of global short-term landscape fire sources PM2.5, quantifying contributions of wildfire urban ozone in Eastern Australia. We've done a lot. And we can explain a lot from the science point of view what comes from any type of fires anywhere, whether it is in this part of Australia, in Australia, or globally. I just would like to bring mention two specific areas. So this is what I mentioned, that prescribed fire, the bushfire season in Brisbane in 2013. Just to give you a taste what kind of information we get. So the measurements, the blue points, you can see that's measurements here using time of flight mass spectrometer. So measurements of CVT, but you can see where the fires take place. So in terms of composition, there was one of the key interests was what's the composition, and that's what we found out. Composition, organic aerosol 64%, and then sulfate ammonium nitride. But in relation to what's specifically could be related or is related to bushfires is organic aerosol. What we found out that fresh biomass burning contributed only 9% to this, but most of this was aged biomass burning. Well, it's not surprising because this burning doesn't happen here. It happens somewhere else. It comes here. Now, why is it important? You can see, well, okay. It is important because when we start talking about health effects, so we need to understand what is the composition, what is in the air, to what people are exposed. So that was the importance from this kind of studies. Very different study, episodes of severe air pollution. This was done with colleagues from around the world and looking at sites around the world using data from around the world. To answer the question, how frequency, intensity, and duration of the severe air pollution changed over time. Now, if you look at this image, and this area's green and red, you can immediately kind of gain understanding or see what we found. Situation is improving in China, Chinese cities, worsening in Australian cities, remaining stable in American cities and varying in European cities. So here in China it's mainly green, but you can see in Australia it's red. Is it surprising? Maybe. But why it is like this? Well, the key is the reduction of emissions from anthropogenic sources. And this is what's happening, well, in particular in China. But this has also happened in Australia. In terms of emissions, we are reducing emissions, controlling emissions. We are very advanced. So why is it worsening? Because of climate-induced severe air pollution. And this is something which we can't really control. And as forecasted, it will be getting worse. So this is this climate affected side of the story. And a very recent study, which will be discussed, I think, in one of the afternoon sessions, impact of wildfire on urban air quality. As usual, Sabor here, we're talking about this. Again, I'm not going to describe the details. But here the question was, what was the concentration of different kinds of pollutants? We are talking about particulate matter. Is it only particulate matter or what else? Basically, we found that all measured air pollutants were generally higher during wildfire periods, and we are talking about here in the city. But during severe wildfire periods, severe when here wildfire concentration was over 25 micrograms, then also all the increase. So this kind of studies on concentrations, understanding the dynamics, physiochemistry, and so on, and the impact on health is what we've been doing here. We've been doing here, but if you saw the list of co-authors, there were colleagues from Queensland, from Australia, from around the world. We've been always working from interdisciplinary, international groups of people because this is such an interdisciplinary topic. And this brings me to this collaboration. Our partner in this event and colleagues with whom we've been working for a long time in many different ways is the Center for Safe Air. After this event, And I'm very pleased to welcome the director of the center, Professor Faye Johnson, who is sitting there. Professor Johnson has been working on this topic before she moved to Tasmania and before she became the director of the Center for Safe Air. The first publication of UFA I saw, in fact, from Northern Territory. That I'm sure we will be talking about this. So how it came to this event? We were actually very fortunate. It was last year when this very knowledgeable, capable person here, Dr. Dwan Vilcins from UQ, received a fellowship from this Center for Safe Air, and her expertise is exactly in this topic. So over many discussions and working together, we thought, well, time is right to bring everybody and talk about this whole big area. So that's why we are here. I guess with this, I'll invite you to continue.
Thank you so much, everybody, for being here. And I want to particularly send a warm welcome out to all of the fire practitioners who came along today, and particularly the Quadrilateral Rangers who have come out with Darren Burns. So it's just really lovely to have you guys here as part of these conversations, not just all the scientists. So thank you so much for everyone who made the effort to come today. So we have 4 big questions that we're hoping to kind of get discussions around. So the first is how climate is affecting the fire risk and the landscape in Queensland. And sorry, Rachael, you did ask me to minimise that. What does the science tell us about controlled burning? What does the reinvigoration and growth of Aboriginal cultural burning mean for wider land management? What do we know about the health impacts of landscape fire smoke? And what options are available to protect the health of communities affected by smoke? Now, of course, we're not going to be able to answer all of these questions today, but we do hope that the range of different discussions across the panels and our presenters will kind of get us thinking about how we work together to start to answer some of these questions. Just to give you a quick overview, presentations until 10:50, coffee break and a group photo, so don't run away from that, please. Then our first panel session, lunch and coffee until 1:30, another set of presentations, panel session, and then Lidia will do a wrap-up with some conclusions, and we will do a wrap-up with conclusions and the way forward. So why these topics and why have we come together today to discuss this? And it's really, to my mind, that responding to the complexity of landscape fires and smoke requires really holistic thinking about both the problems and the potential solutions. We tend to work in silos where we have the policymakers, we have land managers, fire team members, communities, clinicians and health workers, researchers, and the broader environments that we live within, all working kind of independently on our little patch of the problem, but we need to actually come together if we want to find the best response for keeping communities safe from both bushfire risk, but also the risk of the smoke effects. And so this Thrive and Centre for Safe Air joint forum brings together the speakers and panellists that we think are ready to get us thinking through these topics together. And it is possible, and I want to use a little example from some of our own work, the EMBA study, to start to think about these issues holistically, even just within the types of science that we do. So some of you will be familiar with EMBA, the Environmental Measures of Bushfire Smoke Exposure and Respiratory Health Study, and EMBA essentially has 3 different arms to start to bring together this holistic picture. We have studying the health of households that are affected by bushfire smoke events. And we can see here in this, I should have probably put a little thing, sorry, I don't know whether so our kind of public health advice at the moment is to go indoors during a bushfire smoke event, but we can see from EMBA that at every time period, pre-burn, during a burn period and after the burn, indoor air quality is actually far worse than the ambient air quality. So the advice just to go inside and close windows and doors is actually incomplete, and we need to think in a more nuanced way of how we protect and give advice to households. EMBA also looks at the types of pollutants and persistent pollutants in households. So when we do have air pollution events, the air does clear, but then we have pollutants that settle in dust, including environmentally persistent free radicals. And this little guy is Eddie the Alpha. Darren, this is actually from a children's book that we wrote to help introduce children to air pollution and some of the components. And that's where your my conversation this morning got me thinking about some options there. We also work with communities through a Centre for Safe Air funded project to actually build smoke-ready kits. So this is like a storm kit that you can have ready in your cupboard. So when there is a smoke event, households actually have the resources to address their risk and reduce their exposure and try and have a healthier outcome during a smoke event. We go and see fire teams, and so several of you are in the room, and I actually want to give a little shout out to Mel Cooper here from Brisbane City Council in the front row, who really was the first person who introduced me to including the fire team. So this is a perfect example of, I was in my science silo, you're in your fire team silo, but we came together and now we're working together, not just on studying your health, but finding solutions as well. So massive shout out, Mel, for that. Thank you so much. So we even bring the fire teams together to do co-design, because I can come up with all the questions in the world, but until I find out what the fire teams actually need to protect their health, we're not going to be doing the right type of research. And lastly, we're looking at novel methods of measuring different pollutants, such as multi-pollutant sensors that can be attached to the base of drones and flown through smoke. So this is an example of how you can bring different stakeholders and different projects together under one umbrella of a science project to start to answer some of these tricky questions. And why I wanted to show it as an example is I wanted to show that we have a lot of commonalities here. So through EMBA, I'll speak to a lot of scientists and epidemiologists about the health risk of smoke. And we know that there's a lot of risk from putting smoke in the air, whether it's from planned or unplanned fires. And we know that we can match that to things like all-cause mortality, respiratory hospitalisations, and use of inhalers. So we know that is one problem that we're facing, and the scientists are concerned about that. But then when I'm in people's households and I'm talking to families about their risks, they have another take on their concerns. So they're worried about the health of their family, how they can stay safe, how do they protect their asthmatic child. Then when I'm out with my fire teams, I hear about their concerns, and they have lots of concerns. They're concerned about doing a really good job in their work so they can keep our communities safe. They're worried about looking after the environments because they're really passionate about the environments that they work within. And of course, they're concerned about keeping their own team members safe so they can have long, healthy careers and retire feeling really good about the career that they've done. And then I go and speak to communities such as the community out at Dowdy, where we were presenting our smoke-ready kits to that community. And they had those dual risks where a few years ago they had a massive bushfire event and lost property and people had to evacuate the town. But then they lived with 6 weeks of continuous smoke. So they've got this really complex relationship with fire with these multiple factors. And I have these conversations with all these different elements, but there is one central thing, and that is even though we're different stakeholders, we have common goals and concerns. We want to protect people, we want to protect communities, we want to live healthy lives. And so we don't need to work in silos. We can come together and address these really complex problems. And so this Thrive Centre for Safe Air Forum is an opportunity for us all to hear from diverse viewpoints, to learn from each other, to discuss these difficult topics, to find our common ground and to work together on our common goal. And so with that, I would like to welcome our first speakers. And so our first session is on climate impacts, controlled burning science and cultural land stewardship in Queensland. And we've brought together a range of different speakers and stakeholders to give you different views on this topic. And hopefully by the end, we'll have a more common understanding of what some of the problems are. How are we going for time? Look at us, we are on time already. I will be putting up my little time cards for our speakers, just so you know. But it is my great pleasure to announce our first speaker, who is Associate Professor Andrew Dowdy from the University of Melbourne. He'll be talking today on fire and climate change in the Queensland context. So thank you so much. Up and down, Chris.
Thank you very much. Thanks to Lidia for initiating this and bringing this together. So fire and climate change in the Queensland context. So the observations show that the weather conditions associated with dangerous fires are becoming more severe. This is data back to 1950, every day, gridded for Australia, and it shows the forest fire danger index that brings together temperature, humidity, wind, and drought. It's just one way to combine these different factors that we know influence fire behaviour. No index is perfect, but if you interpret it as these are various things that make fires worse in a combined metric, can be useful for this sort of broad-scale climate insight. So looking at that, just these weather factors, there is clearly has been getting more severe over the past decades, and for Queensland in particular, this southeast area and along the coast does appear to be a bit of a hotspot. So this is based on the observations, and we'll see later based on the modelling there's consistent pictures around this as well. When you unpack what's actually causing these trends, it's this lower humidity, so drier air is a key factor there, and that drier air leads to the fuel becoming drier, and so more available to burn. If you unpack that further on a global scale, so globally oceans are warming, but the land is warming faster, and so this difference between land and ocean sets up this thing where the relative humidity, so the dryness of the air relative to temperature of the air over land, there's this difference. And so in this transition period where the land is warming fast, the oceans are slowly warming, catching up, it is exacerbating the fire risk. What does this mean for actually fire occurrence? So this more dangerous weather is leading to more severe, larger, extreme fires. This was a paper just after Black Summer, 2019-20, and maps over decades how many years since the last fire in these forested regions. So blue means sort of 50 or 60 years, and you can see over decades from the 80s up to the last decades, that fire frequency in the forest has become less. And yeah, that Queensland area also then stands out there. If you want to go into this paper, you can see data on prescribed burning. It maps that over the decades, and because in some parts of the media are saying, well, the fires are going up because we're not burning as much. And the data in that paper shows all the prescribed burning from different states, and that it hasn't really changed in a significant way to explain this, but the weather is the thing that does explain this. So, I encourage you to delve into that if you want more details. Yeah, and similar trends, unfortunately, in other parts of the world. So moving to the projections, looking to the future, this is that same index, the Forest Fire Danger Index. What's shown here is two ways to look at severity using a fixed magnitude above 25, so higher values is more dangerous, or you can do a local percentile, so 95th percentile at each location. Different ways to look at extremes. And there's also three different ensembles of models, so each of those rows is a whole lot of models combined, all the data. The first is global climate models, then you've got downscaling to finer resolution using a technique called CCAM, and then another one called WARP. So they're completely independent models. Red means things are getting worse in the future, so whichever way you look at it, different types of models, different metrics, similar trends into the future. And this is the change from a climate period around the year 2000 to a future one around 2070. Looking at Queensland compared to other parts of Australia, there are differences. So in this paper, considered other factors. So how does the vegetation type and arrangements around some of the cities compare? So Brisbane noted there with a bit more moderate compared to some places like Melbourne where there's these higher factors. But so in particular, you've got these sort of rainforest areas around Brisbane. They have this natural fire retardant microclimates, so wet, humid, that is traditionally helps prevent fires getting far into them. But with this increase in the fire weather, we're seeing more patches of this rainforest actually burning, and including in Tasmania and Victoria and other places. So these areas that were traditionally more fire retardant are burning more often, and in some cases growing back with different species and more like acacias and faster growing burning types. So the shift in the actual ecosystem is something that is being seen in some places. So looking another way at projections, this is the observations data that we saw at the start, back to 1950. How often does a black summer, December type of weather conditions occur? In the observations, there's only one, because that was the most extreme we've ever seen. You can see that that blue X there. When you look at the large ensemble of models, you can count how often does that happen. And you can see, as we go into the future, under low emissions, you still get some increase, but under high emissions, the increase is faster, so you get more black summers happening more often. But maybe a take-home message here is we're locked into some climate change, even with the lowish emissions pathway. We'll still have to deal with climate change. But the magnitude of it can be controlled by how fast we reduce our emissions. In terms of adaptation and decision making, it's unavoidable, but the magnitude of it can still be moderated into the future. Now, this is the most recent projections using the latest set of models. Queensland has been the first to get this published for Australia, so the Queensland government has done a great job with the downscaling and getting the science out there. Ryan McLean is actually here, the lead author of this study. So this is the latest CMIP6 global models that are used for the IPCC, Governmental Panel on Climate Change, downscaled to fine resolution, and then here it's the FFDI looking at these 5-year extreme values, so it's very extreme. Similar to what these projections previously showed, using the last set of models prior to this. So this is another independent lot of modelling. Similar picture, increases into the future. Yeah, some variations, less in the tropics shown here than other parts. So that was maybe a lot of bad news there, but maybe some aspect of hope here is that reducing vulnerability can help reduce the impacts. This was produced by the Australasia Fire and Emergency Services Authorities Council, AFAC, as a sort of a comparison of Black Saturday in 2009 around Melbourne, where it's a fairly small area burnt, but large number of lives lost, versus Black Summer, huge area burnt, much fewer proportionally. And there are many factors that go into this. You can't draw exact comparisons, but it's one thing they did say was that part of this difference, significant developments in advice and warnings, together with a more aware and responsive community, appears to be a significant factor. So community awareness and action can help reduce your vulnerability to reduce impacts. One thing we did was make long-range predictions. This is what provided to fire agencies around Australia on the left prior to Black Summer, showing it was worse. The summer after, they said, is this the new normal? Are we expected this? And we said, no, this summer is going to be not as bad as normal. And this is based on things like El Nino, modelling can show these things. So this is a 4 months ahead. This is now capability, so this helps reduce vulnerabilities. Also, giving climate guidance to emergency services, saying things that worked in the past may not work now because the conditions are now outside of anything we've seen in the past. Or data back to 1950 at least. All right, I've been told time's up. Things are getting worse. You can have hope. through improved planning.
I could listen to that for so much longer. Sorry. So now I would love to invite to talk is Associate Professor Rachael Nolan from the New South Wales Bushfire and Natural Hazards Research Centre at Western Sydney University. Rachel's going to be talking today about climate and fire regime.
So I'm going to talk very briefly about the research centre in New South Wales, and then I'll move on to talk about some of the research I've been involved in climate change and bushfires. I just want to start by acknowledging the traditional custodians and knowledge holders of the country where we conduct our research work. So very briefly, the New South Wales Bushfire and Natural Hazards Research Centre was set up in response to the 1920 floods and bushfires. And so one of the recommendations of the New South Wales inquiry into bushfires was that New South Wales become a world-leading research centre in relation to bushfires. So we are 6 universities, and we partner very closely with 7 New South Wales government agencies. We also have Indigenous community organisation that helps us with our Indigenous engagement. We're over 40 researchers now, 15 students, 200 active end user agency participants. So these are people that actually come to our meetings and help us co-design our research. And we're up actually now to about 50 research projects. So we cover an incredible range of disciplines. We divide our research into these themes or working groups, and so we cover everything from collaborative Indigenous research through to field dynamics, backburning operations, smoke impacts, fire weather. I think one of the strengths of our centre is that we bring people together across research disciplines, institutes and across government agencies. And one of the things that I'd really like to highlight is this RFS systems workshop on the bottom, so the New South Wales Rural Fire Service. So this was something that emerged out of a lot of us researchers not really understanding how government works and makes decisions and wanting to know how a lot of things work so that we can then pitch our research to meet government needs. But what I found really inspiring from that was actually a lot of government agencies in New South Wales also didn't know how the rural fire service and so they were also learning alongside us. So I think that's one of our strengths is building those. So I'm going to move on now to talk about climate change and fire risk. So this may be fairly basic ground for some of you, but essentially there's 4 key ingredients that you need to have a fire or that goes into fire regimes. So you need something to burn, that's your fuel. You need that fuel to be dry enough, that's fuel dryness. You need right weather conditions, and you need fire condition. In terms of climate change and how that's going to be affecting those ingredients, there's a number of factors that can affect that. So you've got things like CO2 fertilisation, so the increased CO2 in the air can make biomass growth faster. Increasing temperatures, altered rainfall patterns, drought, heat waves, storms and cyclones, all of these things can affect fuel characteristics. And if that's affecting the vegetation, that's then going to affect the microclimate, that's going to affect fuel dryness. And then we're also seeing changes in dry lightning patterns. So I guess the thing I want to say here is that there's lots of ways that climate change is affecting fire regimes, and there is actually some complexity to this. But also we're not just operating in vacuum, there's many other global change factors happening alongside climate change. And so there's many different ways that fire regimes are shifting through time. And when I talk about fire regimes, I'm not just talking about fire occurrence or frequency, it's also seasonality and intensity. So I'm just going to take a case study now, some of the work we've done in the 1920 bushfires to explain how these factors are playing out. So this is work that the predecessor of our current research centre did. So we had a research centre at our University of Wollongong, and we did a number of research studies into the 1925s for the New South Wales Government Inquiry. This is the summary. Don't worry about the details. I'm going to go through these graphs step by step. So I'm going to start off with work led by Frank Williamson at UTAS. And so what he found was that when you had fire, be it bushfire or prescribed fire, in the years leading up to the 1925s, it did have a protective effect. So he found that you did have lower intensity fire after fire, so that those prescribed burnings were effective. But they're only effective up to about 5 years post-fire. And that protective effect disappeared under extreme fire conditions. Another thing we found was that there was no evidence that fuel loads were enormously high, despite a lot of media conjecture at the time that these fires were driven by prescribed burning. We could find no evidence for that. What we did find was that fuel moisture was the lowest on record. Fire weather was the most extreme on record. And also the majority of the area burns caused by dry lightning storms. So put together, our research showed that these fires were really climatically driven. I want to move on now to talk about what's happened since 1920. So we had that really dry period, we had that flash drought, we had the fires, we then had that rare tripletic La Nina, so 3 wet years in a row. Then we switched into an El Nino, switched back again into El Nino, and we've just had one declare an El Nino for this year. So I really want to highlight where we had a lot of switching back and forth, and this is what has characterised the most recent years. This work led by my postdoc Chris Gordon, he showed that after the 1925s, a lot of people were thinking we would have that protective effect, that we wouldn't have a high fire risk in a number of years because we had all of those fuels burnt. He found that the little loads are still recovering, so the little fuels that are on the ground is still recovering. But because we had those 3 really wet years, the elevated fuels of the shrubs have just exploded. And so what this meant is that years later, when we switched back into El Nino and we had dry conditions, a lot of these areas did actually burn again. And interestingly, because of the change in the vegetation, the fire agencies were actually modelling these as heathland systems, so not as forest systems. So they had to change the way they modelled fire behaviour because the vegetation had changed. Importantly, he found that the effect of the fires wasn't just dependent on if there was a fire or not. What's really important was the severity of the fire and whether it was a long or short fire. So these things do matter in how the vegetation recovers and what the subsequent fire risk is. So I mentioned we had that in 2023, so we had drought here in southeastern Queensland and northern New South Wales. And what we saw is that many areas that burned at high severity between 1920, but again, that high severity 4 years later. So 2 high severity fires within 4 years. And I've got a PhD student who's actually out in the field at the moment, trying to understand what the changes in those ecosystems are. All right, so we had the wet years, we had the dry year, another wet year, and now we're back into El Nino. And these are photos that we got in the last couple of weeks from John Hunter at the University of New England. So this is the New England tablelands in winter with incredible amount of canopy dye. And so this is what's really concerning me about that, because this rapid switching from wet to dry. And you can just imagine if we do have that El Nino play out, and dry conditions, just how fast it's going to be. And at 2 minutes, it'll be really quick. Work led by Alan Price at the University of Wollongong did look at fuel consumption in different fire types. So we're really fortunate to be able to look at cultural burns on the left, hazard reduction burns in the middle, and wildfires on the right. The take-home message is that fuel consumption from cultural burns is much lower, so we suspect that means smoke emissions will be lower. Smoke emissions from hazard reduction burns and wildfires, interestingly, were quite similar, although the hazard reduction burns were a lot more patchy. I've also done some research on what happens to the trees, and this is something that I'm really interested in for a long time about. So what we found after the 1925s is there wasn't a massive increase in tree mortality for a lot of the forest types. But one of the forest types we studied, the Western Slopes reservoir forest on the left, had almost 50% of its tree biomass killed after fire in these normally resilient forests, and we think that's because it was more drought affected. And so why does this matter? Well, I'm really interested in it in the context of carbon stocks, because Australia invests quite heavily in offsetting carbon emissions from forests. But, of course, when you have a lot of dead trees from one fire, when you get another fire, these are going to be producing smoke. And so you can see here, this isn't even completely dead, it's just quite stressed. And in this pretty low intensity fire, you can just see the smoke pouring off it. So what happens in one fire and the tree mortality you get is really going to set the template for potential smoke emissions.